Hello, this is Serene from Exam Help Lab. Today I'll be solving Chemistry Paper 2 AS Level Structured Questions 9701 Paper 2 Range 2 Major in 2018. Question number 1. Sodium and magnesium are the first two elements in the third period. Sodium and magnesium both react with cold water to produce the same type of product in solution. With sodium, the solution is clear, but with magnesium it appears cloudy. Part 1. Write an equation for the reaction of magnesium with cold water. So magnesium with cold water, this reaction gives us magnesium hydroxide plus water, whereas magnesium with hot water would give us magnesium oxide plus water. Part 2 suggests why the solution is cloudy after the reaction of magnesium with cold water. So that's because magnesium hydroxide is slightly soluble than sodium hydroxide, because on top of group 2 elements, hydroxides, they are less soluble as compared to those which are at the bottom. Part B, group 2 elements including magnesium react with oxygen and with dilute acids. There are trends in both the physical and chemical properties of the elements and their compounds down the group. Reactivity generally increases from magnesium to barium. Explain why there is a general increase in reactivity from magnesium to barium. So magnesium to barium, the number of electrons, they increase in the outermost shell, but they are added to the shell which is farther to the nucleus each time we descend group 2. So this increases shielding, and hence force of attraction gets weaker between outermost electrons and nucleus, those which are down in group 2. So this way these metals will be able to lose their outermost electrons much more easily, and the reactivity of the elements from Mg to Ba increases. So the first point is that magnesium to barium shielding effect increases. This was the first point. This shielding will result in decreased force of attraction or weaker force of attraction between outermost electrons and nucleus. You can write that force of attraction gets weaker down group 2 between nucleus and outermost electrons. This will lead to atoms losing their electrons much easily. But only those which are down group 2. Part 2, give 2 observations for the reaction of magnesium with oxygen. Write an equation for this reaction, includes state symbols. So magnesium in solid form plus oxygen, which is gas, that gives magnesium oxide, which is also solid, 2Mg, 2MgO. So magnesium, when reacts with oxygen, it burns an oxygen. Magnesium oxide will be forming, which is a white solid. So magnesium oxide is a white solid. This is one of the observations, one of the 2 observations. And the second observation would be the flame with which magnesium burns. And magnesium burns in oxygen with white flame. So you can write that magnesium burns with white flame. Part 3, write an equation for the reaction of magnesium with sulfuric acid. So metal plus acid gives salt, that is MgSO4 plus hydrogen gas. Part 4 suggests why there is a general decrease in the melting points of the elements down group 2. So elements down group 2, they have their electrons in their outermost shells, which are at greater distance from nucleus as compared to those on the top of the group. So this means that atoms that have their outermost electrons much farther from nucleus, they will be experiencing greater shielding, and that also leads to increase in ionic radius, which decreases attraction between electrons and ion's nucleus. So the first point could be that shielding increases down group 2 and ionic radius increases too. This leads to weaker force of attraction between electrons and the atom's nucleus. And when force of attraction gets weaker, this will require much less energy to break those bonds. Question number 2, ammonium iron 2 sulfate has a relative formula mass of 284. Define the term relative formula mass. So this is mass of 1 mole of a compound as compared to 1/12 of 1 mole of carbon 12. Part B, one of the cations in ammonium iron 2 sulfate is the ammonium ion NH4+. Draw a dot and cross diagram for an ammonium ion. Show outer shell electrons only. So NH4+ has NH3 ammonia with covalent bonds within the molecule, and H+ ion having a dative bond with NH3. So NH3, and will be sharing each of its 3 electrons with 3 hydrogen atoms, and 2 of its electrons, which will form a lone pair of electrons over here. This will be attracted towards an H+ ion that will not be having any electron with it. So H+ will be attracted towards it, and this will form as a structure combining covalent and dative bonding. So H, 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 and H, and we'll have a combined charge on this structure of positive. Part 2 suggests the shape of an ammonium ion and predict the bond angle. So shape is going to be tetrahedral, and bond angle is going to be 109.5 degrees. Because just like CH4 methane, NH4+ now has no electron lone pair. So there is going to be equal amount of repulsion between the bond pairs. Part C, in aqueous solution, the ammonium ion acts as a weak bronzed-Lowry acid. Explain the meaning of the term weak bronzed-Lowry acid. So a weak acid is one which partially ionizes into a solution, and a Lowry acid is one that donates proton. So introducing the term weak, which is acids that partially ionize into solution, followed by the explanation of bronzed-Lowry acid, and is a proton donor. Part 2, write an equation to show this behavior of the ammonium ion in water. Include state symbols. So ammonium ion will be acting as a weak bronzed-Lowry acid. So NH4+ in an aqueous state reacts with water, which is in liquid state. Now NH4 will act as a weak acid, means it will be donating 1 proton to the other substance. So this will become NH3 in aqueous state, and H2O will now be H3O+ in aqueous state. Part D, Mohr salt is the hydrated form of ammonium iron 2 sulfate. X represents the number of moles of water in 1 mole of the salt. A student wanted to determine the value of X. 0.784 grams of the hydrated salt was dissolved in water and the solution was acidified. Okay, so this amount of hydrated salt was made a solution. All of the solution was titerated with 0.02 mole per decimeter cube of potassium manganate. 20 centimeter cube of this potassium manganate solution was required for complete reaction with Fe2 plus ions. Use changes in oxidation numbers to balance the equation for the reaction taking place. So MnO4 minus, here manganate has an oxidation state of +7, while over here it has an oxidation state of +2. So there is a decrease of 5. Now, Fe2 plus has an oxidation state of +2 and Fe3 plus has an oxidation state of +3. Now here there was an increase of +1. Rest, they have their oxidation state constant. O4 has an oxidation state of -2 and it's -2 over here as well. At shear, they share the hydrogen atoms or ions, they share the same oxidation states on both sides of equation. So now we need to balance this equation. We will have to multiply this with 1 and we will multiply this with 5. So we'll have 5 moles of Fe3 plus and 5 moles of Fe2 plus. Here we are going to have 4 moles of H2O and we will have 8 moles of H plus ions. Part 2, state the role of the Fe2 plus ions in this reaction. Fe2 plus is oxidizing itself and it is reducing MnO4 from +7 to +2. This way we can say that Fe2 plus is acting as a reducing agent. Because it oxidizes from Fe2 plus to Fe3 plus. The reducing agent will get oxidized itself and an oxidizing agent will get reduced itself in an equation. Part 3, calculate the amount in moles of manganate 7 ions that reacted. So we were given the concentration of manganate ion being used and the volume of the manganate ions. Now moles is equals to concentration multiplied by volume, since we are given volume in centimeter cube, which we need to convert into decimeter cube. So we'll divide this by 1000 and we'll have the amount of moles of manganate ion as 0.0004 moles. Part 4, calculate the amount in moles of Fe2 plus ions in the sample of the salt. So according to the equation, 5 moles of Fe2 plus react with 1 mole of manganate ion. So 0.0004 of moles of MnO4 minus iron from the previous part would need 5 into 0.0004 moles. And we will have 0.002 moles. And all of the Fe2 plus had reacted with 20 centimeter cube of manganate ion. So none of them were remaining. Part 5, calculate the relative formula mass of this Mohr salt. So relative formula mass is equal to mass divided by moles. Mass of the Mohr salt, which we are using in this equation, which we are using in this reaction, is 0.784 grams. And the moles of this Mohr salt from the previous part, and that is of Fe2 plus, is 0.002 moles. So the relative formula mass for the Mohr salt is 392. Now part 6, calculate the value of X. Now to get the value of X, you should be subtracting MR of anhydrous Mohr salt, that is NH4 twice FeSO4 2 without the water molecule, that is anhydrous salt, from the MR of hydrated salt, which means hydrated one would be combining this XH2O. Now the MR of hydrated salt is equals to 392. Now that of anhydrous 1 is equals to the relative formula mass for this formula. and that is 108. Subtract 108 from 392 and divide that by 18, since that is the MR for water molecule, for 1 mole of water molecule, and you will have the value of X as 6. Question number 3. Most vehicle fuels contain hydrocarbons obtained from crude oil. Part A1, state the name of the type of reaction that hydrocarbons undergo when being used as fuels. So that's combustion, because these fuels, they burn in oxygen. Part 2, write an equation for the reaction of octane as a fuel in A part 1. So combustion of C8H18 octane would give carbon dioxide plus water. Here we're going to have 8, 9, and 25 by 2. Part B, the supply of material suitable for use as fuels directly from crude oil is not sufficient to meet demand. A process is carried out to make some of the larger hydrocarbon molecules more useful. Part 1, name this process. That's cracking. Because fuels that we use contain small carbon chains, on the other hand, materials that we get from crude oil directly are of those with large carbon chains. So those with large carbon chains wouldn't be of no use. As well as producing fuels, this process produces compounds suitable for use in the production of polymers. An example of such a compound is butene. Draw the repeat unit of the polymer that is produced from butene. So butene is C to C double bond, hydrogens on the top, and CH3 and CH3, 2 methyl groups. Now, the polymer would be breaking of this double bond and forming these 2 new single bonds, and the rest will remain the same. And a single repeat unit would be brackets and N. Part 3, name the type of polymerization that occurs during the production of the polymer in part 2. So this kind of polymerization is known as addition polymerization. Part C, gases produced in internal combustion engines include carbon monoxide, oxides of nitrogen such as nitrogen dioxide, and unburned hydrocarbons. These gases are removed from the exhaust before they can enter the atmosphere. State what is used to remove these gases from the exhaust. So we use catalytic converter in our car exhaust to convert all these harmful gases like carbon monoxide and oxide of nitrogen to less harmful ones. Part 2, write one equation to show how both carbon monoxide and nitrogen dioxide are removed from the exhaust. So carbon monoxide reacts with nitrogen dioxide. This converts to nitrogen gas and carbon dioxide to CO half 2. Part 3, state the environmental consequence of allowing unburnt hydrocarbons to enter the atmosphere. So this causes global dimming. Part D, vehicle fuels are treated to remove sulfur. If sulfur is present in a fuel when it is burned, sulfur dioxide is produced and may be released into the atmosphere where it can form acid rain. Acid rain can contribute to breathing difficulties. Identify 2 other consequences of acid rain into the atmosphere. So acid rain can also lower pH of rivers or lakes or oceans, that is threatening to all the marine animals. And the second is it could damage limestone buildings. Part 2, nitrogen dioxide is involved in the production of acid rain from sulfur dioxide. Give 2 equations which describe how acid rain is formed by the action of nitrogen dioxide with sulfur dioxide. Now to form acid rain, we need sulfur trioxide, and this basically happens here. When nitrogen dioxide reacts with sulfur dioxide, nitrogen dioxide contributes because nitrogen dioxide oxidizes sulfur dioxide to sulfur trioxide and itself become nitrogen monoxide, and now the sulfur trioxide reacts with water to form H2SO4, that is acid rain. Part 3, nitrogen dioxide is described as a catalyst during this process. Explain with the use of an appropriate equation why nitrogen dioxide is described as a catalyst. So nitrogen dioxide, it remains chemically unchanged in this reaction. When nitrogen dioxide reduces to nitrogen monoxide, this nitrogen monoxide will again react with oxygen to form nitrogen dioxide, which proves that nitrogen dioxide remains chemically unchanged and is described as a catalyst during this process. So nitrogen dioxide remains chemically unchanged. The reaction between W and alkaline aqueous iodine produces a yellow precipitate. Give the name of the compound formed as a yellow precipitate in this reaction. So W is a ketone, and when ketone reacts with alkaline aqueous iodine, triiodomethane forms, which is yellow precipitate. Give the name of W, that's butanone. There are two structural isomers of W that are also carbonyl compounds. Show the structures of these two isomers of W. So carbonyl compounds includes ketones and aldehydes. W is C4H8O. So the two structures which they are asking us to draw over here could be of aldehyde groups. So one could be having the aldehyde group on the very first carbon atom, and the second could be having again an aldehyde group on the first carbon atom, but a methyl group on the second carbon atom. Two reactions of W are shown. See part 1. Identify the type of reaction occurring in reaction 1. So reaction 1 is ketone to secondary alcohol group. So this is reduction. And reaction 2 is ketone to alcohol group and a nitrile group, which is a nucleophilic substitution reaction. Nucleophilic because nitrile ion is a nucleophile acting over here. Identify the reagent for reaction 1. Now to turn ketone group back into secondary alcohol, we can use any reducing agent, either LiAlH4 or NaBH4. Let's say that I use NaBH4. The only difference between LiAlH4 and NaBH4 is that LiAlH4 can reduce both acids and ketones, while NaBH4 doesn't have enough power to reduce acids or aldehydes back into primary alcohol. It can only reduce ketones back into secondary alcohols. Part D, reaction 2 is carried out by adding a mixture of HCN and NaCN to W. The product X is formed as a mixture of two isomers. Complete the mechanism for this reaction. So in the first step, C2O double bond will be breaking heterolytically. C will be having a partial positive charge and O will get a partial negative charge. We'll have an arrowhead towards O. And Cn minus will have a lone pair of charge, and this Cn minus has come from the catalyst NaCN but not HCN, which will be attracted towards this partial positive carbon atom. Now the second intermediate product would have single bond O with oxygen having a lone pair of electrons and a negative charge. Everything will remain the same, except that now it will be having a Cn ion attached to it. Now this lone pair of electron will be attracted towards H plus that had come from HCN. Part 2, state the name of the type of isomerism shown by X. So this structure shows optical isomerism because there is the central carbon atom that is attached to 4 different group of atoms. So optical isomerism. Part 3, explain fully why X shows this type of isomerism. Again, that's due to central carbon atom attached to 4 different atoms. And since this part of question is of 2 marks, so we need to mention 2 reasons. The other reason is that it also has, structure X also has a non-superimposable mirror image. Part E, if X is treated with ammonia and the product hydrolyzed, a compound Y is obtained that contains 51.3% of carbon, 9.4% of hydrogen, 12% of nitrogen, and 27.3% of oxygen by mass. Show that the empirical formula of Y is C5H11NO2. So carbon, hydrogen, nitrogen, and oxygen. Carbon is 51.3% by mass, hydrogen is 9.4% by mass, nitrogen is 12% by mass, and oxygen is 27.3% by mass. Now we need to divide all these with their respective relative atomic masses. C has a relative atomic mass of 12, 1 for hydrogen, 14 for nitrogen, and 16 for oxygen. Now you divide them and get the number of moles they have in this formula. So 51.3 by 12 is 4.275. 9.4 by 1 is 9.4. 12 by 14 is 0.857. And 27.3 by 16 is 1.70625. Now you need to divide all these by the smallest here. So all of these will get divided by 0.857 to get the smallest whole number ratio. So 4.275 by 0.857 is 5. 9.4 by 0.857 is 11. 0.857 by 0.857 is 1. And 1.70625 by 0.857 is 2. So this proves that C5H11NO2 is the empirical formula for structure Y. The empirical formula of Y is C5H11NO2 and the MR of Y is 117. To deduce the molecular formula of Y, you must explain your reasoning. So to get the molecular formula of structure Y, you have to divide MR of Y, which is 117, by empirical formula mass of Y, which is again 117, which is equals to 1. So we can say that molecular formula of Y is exactly the same as empirical formula of Y, and that's C5H11NO2. Your reasoning would be that your empirical formula mass is equals to molecular formula mass. That was the end of the paper. Thank you for watching.